We want to continue the examples that we've been solving, and this will be the 6th and 7th example I promised you. And after that, we're going to look at 8 and 9. If you notice, we have acquired the skill of how to apply the law of indices in this situation, looking at whole number, looking at fraction, indices, and also decimal to fraction. Now, question number 8 and 9 is still part of indices, and it really incorporates quadratic equation. We're going to delve into quadratic equation in our subsequent videos, but for now, we're going to apply the concept to be able to determine the value of x in this situation. Just for us to start, let's begin with question number 6 where we stopped. So we have 9 raised to the power of x equals to 1 over 729. So how do we address this? There are two ways by which you can address it, and want to make it simple. And each time you have any question on indices, look for a way to make it simpler to address. So I want to make it simpler by saying 9 raised to the power x and applying that reciprocal, 729 raised to the power minus 1. If you look on both sides, they are both big numbers. We can look for the factor on the left hand side and the right hand side. So this is the left hand side and this is the right hand side. So what is the factor of 9? Or what two numbers can we multiply together that will give us 9? Pretty easy. 3 will do that, right? So we have 3 to the power of 2 raised to the power of x. Now 729. We need to determine the factor or the root number that will multiply repetitively. It will give us 729. Something give me the clue, like in previous question 9. So you can try to check it out first. 729 by 9. So it will go 81. And 9 will go in 81 9 times, and 991. So we have 9 raised to the power 3. That is one way. So we have 9 to the power of 3. We have really brought 729 down. We can take a step further by saying 2 raised to the power 2x, and this is 3 raised to the power 2 and 3. Because 3 times 3 is 9. So don't forget, we still have our minus 1. So 3 raised to the power 2x will give us 3 raised to the power. You'll notice that we have the law that we can apply to help us, k raised to the power m and n. And that will give us k raised to the power mn. So based on this, we have 3 times 2. And this is 3 raised to the power 2x equals to 3 raised to the power 6. We don't want to forget the minus 1. So 3 raised to the power 2x equals to 3 raised to the power minus 6. Applying that law. On both sides, 3 will cancel out, and we have 2x equals to minus 6. So based on this, we can now determine the value of x by saying divide both sides by 2. So we have 2x over 2 and minus 6 over 2. And if 2 cancels out, we're going to have x equals to minus 3. So that really helps us there to determine that value. So you can see clearly in this case for number 6 We'll now take number 7, 32 raised to the power of x equals to 0.25. We can apply the same law, decimal to fraction and fraction to decimal. So we have 32 to the power of x and 25 over 100. So based on what we are looking at now, we can look for the factor on both sides. But let's bring it down. We have, so this will give us 2 raised to the power 5 into x and 4 raised to the power minus 1. Remember, we always want to go to the lowest root and make sure what you have on the left hand side equals to what is on the right hand side. So we have 2 raised to the power 2 because 2 times 2 will give us 4. And then we have 2 raised to the power 5x and 2 raised to the power minus 2. Applying that law. 2 on both sides we cancel out. 5x equals to minus 2. We apply that algebra concept. To determine x, we divide both sides by 5. So 5x over 5 and minus 2 over 5. So therefore, x will be equals to minus 2 over 5. Please play around with these exercises, improve your skills, and you will always get better. Thank you very much for watching. We're going to discuss the 2 exercises in the next video.